Okay, so today we're going to look at matrix multiplication. So that's actually when we're going to have a matrix multiplied by another matrix. So yesterday we looked at scalar multiplication, which was a number out the front. This one is a matrix by matrix. Now, there's rules that happen. So you can't multiply any matrix with another. It's not always possible. And what you have to do is you have to look at the order of the matrices. And also the one that comes first is also like the order of which one you're saying you're multiplying, like post-multiplying, is also important. So what you do, so if you have a look up here, I'll just put a little example underneath. So say matrix A had the order of a 2 by 3. If I want to be able to multiply another matrix after that, so matrix A with another matrix, it must have the same amount of rows as that matrix A had in columns. So what I'm pretty much saying is that these two numbers, they need to be the same. So they have to be equal. So what we normally say, if the number of columns in the first matrix equals the number of rows in the second, we say it's defined. So if it's possible, if you're able to do it, they'll use the word defined. So when it's defined, that means you can do it. And what your answer will have an order where it will take the rows of the first one and it will have the columns of the second one. So that's what the order it will have. The answer will look like that. Okay, so that must happen. Now, write a little note. See how this is written in yellow? So when they ask you, explain why two matrices can be multiplied together, that can be multiplied together, you are going to write like that statement out in that yellow. You must write that wording. Don't write when they say, don't write like draw the orders and write equals. No. When they say explain or write why, you're going to write that. Obviously, you may have different letters. It might not be matrix A, it may be another matrix and so on. Okay? So, for them to be defined, we know that the columns in the first have to equal. So if we go down to these examples down here, what we're seeing here is when they say which of these following are defined. So when you see the letters next to each other, what that means is they're going to multiply matrix A and after it with matrix B. So if you put the orders underneath those, so just underneath there, A has an order of a 2 by 2 and B has an order of a 2 by 1. So because these two are not equal, so it's not defined. So they're asking me which of the following matrices products. So they may use the word product. That's another word for multiplied or times. Okay, so if they say that, that's what they're talking about. So if we check out the next one and we had matrix B multiplying with matrix C, so it would have been B is a 1 by 2 and C is a 2 by 1. Now, is that one defined? Yes, because they're equal. Okay, so B is a 1 by 2 and 2, so it's equal. So yes, we'd say this one is defined. Okay, and if I was asked to explain, I'd say these two are defined because the columns in B equal the number of rows in C. Okay, and if we check this last one, we would have had A times C. And if we put the orders underneath, A was a 2 by 2, C was a 2 by 1. Is this one defined? Yeah. Yes, because they're equal, so it's defined. Okay, if we look at this next question here, where they're asking us, are they defined? And then what would the order of their answer be? So what you often see is here we're going to do B times A. So first you're going to check that they're defined. So B was a 1 by 2 and A is a 2 by 2. So you say, yes, it's defined. So it's worked, it's defined. And now they want you to write the answer. So when they say sometimes they call it the product matrix because the two have been multiplied together. So when you get this product matrix, they'll put the two letters together inside the bracket to label it like that, okay? Now, knowing that other rule, we know that the order is going to be the same number of rows as that first matrix and the same number of columns as the second. So if that one, when we do that one, it'll work and you'll end up with a 1 by 2. Now, if I look at the next question where they're saying, B times C. So if I just chuck the orders underneath, B was a 1 by 2 and C is a 2 by 1. Is that one defined? Yes, it's defined. And what will its answer be? So I would end up, it is defined, so you're saying I'll get an answer. So I'll have this new matrix, BC, and what will its order be? It'll have 1 row and how many columns? And another 1. Yep, so we're taking from there. Okay, and then the last one, they're saying we've got A times C. Okay, so the order, A was a 2 by 2, C was a 2 by 1. Is that one defined? Yes. So it's defined. So if it's defined, we're going to end up with an answer. So this, it'll be AC matrix. And what order will it have? It'll have a 2 by 1. We're taking from that 2 and the last one there. Okay. So what this note down here is really important to notice. In matrices, you will get different answers. First of all, if they may not always be defined. So see how A times B does not necessarily equal B times A. So you know in our normal multiplication, when we say 2 times 3, that is the same as 3 times 2, isn't it? Yes, but not in matrices. So the order of which one you put first is very important. So we need to be careful with that. Some may be defined, and even though they may be different, you might be able to do it, but it'll produce a different answer. So just be really careful with that. Okay, so what we're going to do, most of our multiplication, if they don't ask you, of course you can use your calculators. You've got your calculators, so you can just times it in. If you times the one that can't be done on your calculator, it will tell you undefined. It'll spit back those words at you, so you know that's wrong. But we do need to know how they actually work it out. So we need to know how to manually, what actually they do when they're working it out. And there's going to be some questions that will test this theory in terms of there's no way you can do it on your calculator. You have to show how it is done. All right, so let's have a look here. So what we've got is we're going to work these matrices out. All right, so what we're going to do is we're going to do like what we just did before. You would check this is a 2 by 2 and this one is also a 2 by 2. So yes, it's defined, so we could do it. And our order is going to be a 2 by 2. So it's handy to know what your answer should look like. And so what I'm saying is it's going to be a 2 by 2. So that means it will have essentially 4 elements. And there's the 4 elements will be worked out like that. Okay? So what they often say when we are talking about manual multiplication, we often say we run along the row, and they might say dive down the column. So what that means is, what you can see when we calculated, say this first element up here, this element is in the answer, this element is in row 1, column 1. So what it did is it took the 2 elements from the row 1 in the first matrix and it multiplied them with the 2 elements in the column of the next matrix, and then they added them together. So you can see here, this first number gets multiplied with E. So there's the A and the E, and then if you look at the B, got multiplied with the G, and then you add those 2 together and you get the answer. So then if I had to go and do, say, this, if I was trying to work out what this element was, this one's still row 1, but column 2. So I would be using, you can see I use A times F plus B times H, and there you go. You need to take your time and you must practice this and slowly and get good at it, because then that will give you the advantage of doing it. So let's have a look. You can see we've asked us to multiply. So here they've written out matrix A and to multiply with matrix B. So if we just checked up here, always check that you can do it, because you don't want to go off and be doing half the work when it's not even possible. So it is defined, and you can see if I did that, my answer is going to be a 2 by 1. It's always really good to work out what your answer is going to be. So you know, all right, it's going to be 2 rows, 1 column. So there's those 2 by 1. So you can see we've gone over here, this top answer element would be row 1, column 1. So it's used row 1 with column 1. And you can see this bottom element is row 2, but still column 1, because you've only got 2, so you would go run and dive with that one, and that's how that works. So then once you've done that, you just tidy it up. All right, so there's a little example there, but what we're going to do is we'll do some more. So here, I'm going to, we're just going to multiply these 2 together. Now, because they're written there, so I'm just going to say we're timesing it here, okay, to save a bit of paper. So we've got 1 by 3, and we've got a 3 by 1. So, yes, it's defined. And what will my answer be? Good. So I'm going to have a 1 by 1. So what I'm going to do is I give myself plenty of room, but underneath I write it's a 1 by 1. So I know that essentially I'm just going to have one element, one answer. Okay? All right, so I go off, I've got one answer, which means I'm going to use row 1, so we run and we will dive. So what will happen is I'll have 1 times 2, so this one with the 2, plus the 2 middle numbers multiplied together, 2 times 4, plus 3 times 1. And then you can just tidy all of that up. So you'd have, this would be 2, 8, and 3. So we end up with 13. And always good to double check that you've only got the one element, which I do, which is good because that's what I wanted. All right, so let's have another little go. So once again, I'm just going to put a multiplication in between there. And we're going to test. So we're going to multiply these 2. So this is a 2 by 2, and this is a 2 by 1. Okay, double check that it's defined. It's defined. And what will my answer be for this one? We're going to have a 2 by 1. Good. So give myself plenty of room. So 2 rows and 1 column. So that means I'm going to have 2 elements, and it'll look like this, yeah? So this is row 1, column 1, this is row 2, column 2. So if you write them on your little answer matrix, it's sort of telling you which ones to use. So you use the row of the first matrix and you use the column of the second one. So if you look here, this one's going to be 1 times 2 plus 0 times 3. So I have used this row with this column, Yeah? And then I'll go again, and I'm going to use the row 2 with that column. So I will have, I'm going to have 2 times 2 plus 3 times 3. Then just tidy that up. Obviously, you can do that on your calculator and check that you're right, but what they do is they ask you to write out that middle step that I'm putting in there, and you have to show that. And the only way, you're probably already going to be given that the answer is, what's that, 2 and 13? Yeah? You're probably going to be told that, but they're going to say, how do you get that number? So there's no way around it. You just have to show working out, and you must practice this. So today when we're doing this topic, make sure you're doing those questions manually, and then also don't go to the back of the book to check your answer. Do it on the calculator, because what that will do is increase your calculator skill and make you quicker, which is what we need as well. All right, so here, when we do this one, just to show you, don't worry about if you've got letters. We'll just do the same thing. So we've got a 2 by 2 with a 2 by 1. So we know it is defined. And what will my answer be? Yep, good. It's going to be a 2 by 1. So we'll do like we always do, and we're like going to set it up. So I'm actually going to have 2 rows with 1 column. So that means like 1 element in each of that. So we're going to do the same. So this is row 1, column 1, row 2, column 1. So I'm going to say 1 times x plus 3 times y. That's the first one. And then I'm going to do the next one. It'll be 2 times x plus negative 4 times y. So how you tidy this up is you just do what you can. Now, we don't have to write 1 times x. I can write that as x, and the 3 times y I can write as 3y. But I can't add them together because they're different. So what is happening is the element will stay with those 2 terms like that. And this one underneath will be 2x minus 4y. So these are your actual element is a little like expression there like that, okay? And that's all you do. You just leave it like that and you've done it. So with this one, if you multiply by an identity matrix, so remember identity matrix has the 1s on the leading diagonal and 0 everywhere else. So if you get the identity matrix and you multiply it by another matrix, now generally, because the identity is a square, so you're going to multiply it by another square matrix. Anyway, you get the same matrix, and we said that earlier. Just make note, so you wouldn't have to go and enter it all in. You should, if you know that fact, if you see an identity and it gets multiplied by another matrix, you'll get the same answer, so you could quickly do that. So what we can have, and they will use it in wording, so you've got to be aware of this. They will call these matrices, we can get they'll say make up a matrix that's a summing matrix. Summing means you want to add something all up, okay? So what we know, if we post multiply, so that means multiply after, yeah? With a column matrix of 1s, it will add up the rows. So what do I mean by a column matrix of 1? I mean like it will look like this. So say this is an example. That's a column matrix full of 1s. Okay, so if you multiply a matrix after that, it will add up the rows. So, and then we'll see that in a minute. And if you multiply before, so pre-multiply, with a row matrix full of 1s, so that would look like this. If you pre-multiply, you will add up the columns. So it just depends what they're wanting you to do, and you need to do that. So if you look here, it says here the display row sums of the matrix. So what they want you to do is they want you to add up these rows. So if you want to add up the rows, you need to, we just read it, we need to post multiply with a column matrix of ones. Because if you times something by 1, do you get the same number? Yeah, so by multiplying it by 1, we're not adding any value, but we do end up adding them up. So what we're going to do here is, first of all, what's the order of this matrix here? It's a 5 by 5. Good. So what I really want to do is, they said, can you add up the rows? So they want these row numbers added up. And you could just quickly check and you'd go, all right, if you added them up, if we add them up, we should get 22, okay? So, but what they want you to do is they want you to show how you can do it with matrices. What can I multiply this matrix with to add up the rows? So what I'm saying is, I'm going to do a column matrix full of ones. Now, because this is a 5 by 5, it's got 5 rows and 5 columns. I want to put, this one needs to have 5 rows, yeah, so that it'll match. So this one ends up being a 5 by 1. So if we just, to show you, if we were manually like doing this, we can see we'd end up with a 5 by 1. So we'll have a 5 by 1 answer. And what will happen, so we'll have, this would be, you know, all across here, and you'd have 5. So I'm just going to do 1, 2, 3, 4, 5, okay? So it will look like that. Okay, and then if you run and dive, so you can see it would be 2 times 1 plus 4 times 1 plus 1 times 1 plus 7 times 1 plus 8 times 1. And you can see when you do that, you'll end up with 22, which is what we knew we should get. So if you just quickly chuck that matrix in and times it by a column, you'll end up with a sum, all those rows added up. So you can see what that is. And this is why, you know, people ask me, why would you use matrices? This is how computers will have to see that. You know, if you're putting data in and they want to add up the rows, computers have to deal with, like, you know, digits and numbers. They can't, like, do that. So this is where it's all in sort of coding and computing. So anyway, so if we want to sum up the rows, we times by a column. And then if we want to, sorry, I've run out of room here. But if we want to add up the columns, we're going to pre-multiply. So that means before. Pre-multiply with a row matrix of 1. So I'm just gonna, sorry, I'm gonna zip and small, making a little bit more room here. Yeah, so what we're gonna do, we need to pre-multiply. So this one is, if I think of the order, this one is a 3 by 5. So I'm gonna pre-multiply. So that means I'm gonna multiply a matrix in front. So if I'm multiplying it in front, this one has to have 3 columns. And if I'm going to add up all the columns, how many rows have we got there? So it's gonna be, oh God, what am I saying? No, sorry, we want to just add them up. So we want a 1 by 5, yeah, because we want to add up all the columns. So all you have to do is, obviously, when we go to pre-multiply, we're going to have a 1 by 3. And then we're going to multiply, and I'm just going to write out that matrix again. So you don't have to do it manually, obviously. You just have to show what you would pre-multiply it with. So we've done that. I just showed you to prove it, you know, and to explain the manual multiplication. Sometimes they might just ask you, you know, how did you find this one element? So you only have to show one bit of working out. All right, so when we do that, obviously just quickly looking, the first column should add up to 8, and that's what you'll get. And the next one, 10, 6, 14, and 11. So if you did this part in your calculator, you'll end up seeing this answer there. Okay? So if you get a little bit lost and you can't remember which one you have to do, just come back to this page, yeah? You've got your notes and you can do that.